So next up, we have Dr. Susan Redline, who's a professor of medicine at Harvard Medical School and Brigham and Women's Hospital, and she co-directs the National Sleep Research Resource. For you, Susan.
Hello. Okay, next slide, please. Okay, well, thank you for the opportunity to speak today. And I'm going to come with a bit of a different perspective. I manage a very specialized resource, the National Sleep Research Resource, which was originally funded by the National Heart, Lung, Blood Institute as a grant. And because of the apparent or perceived positive impact on the sleep community, we were actually awarded a contract from NHLBI to further develop, support and develop the resource and actually look forward to even moving the resource into the Biodata Catalyst Cloud. And what I'm going to talk to you really is and make the case that I think our resource can actually be a use case for some of the things that have already been spoken about this morning in terms of really challenging and developing and really testing ways that data metrics can be utilized in a real world setting with some special applications. So I'm going to begin by just talk about really this domain resource with the real potential impact on the field and some of the challenges we've had in creating this repository and tool set, and how we want to measure how we overcome those barriers. I will then talk about really the initial structure of the National Sleep Research Resource. I'm going to talk to you then about how we've begun in really very preliminary ways to define the impact we have on our user community, and then just summarize some of the challenges. The next slide. So I always am a fan of trying to enforce upon people the potential of sleep data, which is often not recognized across many communities. And in fact, there's a huge reservoir of overnight sleep physiologic data. There are about 3,000, in the clinical realm, there are about 3,000 accredited sleep labs doing about 1 million sleep studies a year. Each sleep study, together probably generating 400 terabytes of data a year. That's generally not tapped into. And then NIH, as well as industry, funds multiple studies. I just show you the logos of a few of the NHLBI studies that I've worked with, from Framingham through Mesa, through Hispanic Community Health Study, that have all included objective measures of sleep with opportunities to pull those resources. Next slide. And next. Next. I'm sorry, go back, please. Something didn't appear. Okay, there's something that isn't showing, but again, this slide, sorry that half of it's missing, just really emphasizes the complex overnight physiologic data. We collect multiple channels of data. That one snapshot on the left is actually just a minute of data, and we collect 8 to 10 hours of this data. So it can do a lot of very dynamic types of data access. Next slide. Next, please. Okay. And the interesting thing about sleep is that our data really become richer when we link our data to sort of upstream causes like the environmental, social, economic, psychosocial factors that influence sleep, link sleep to both physiology, genetics, and behavior, and then ultimately relate sleep to changes in a broad variety of clinical outcomes from brain health through cancer, as well as looking at developmental issues. So the value of a sleep resource is not only to provide these physiologic data, but be able to link the data to other domains. Next. So a number of years ago, when we approached NHLBI to fund us as a research resource grant, we actually identified how nicely some of our aims were with the overall big data to knowledge initiatives underway at that time, and the opportunities to even really fortify the sleep community and really help support the establishment of networks and training, and address a variety of sleep topics that really, undergo discovery of new biomarkers in sleep to really understanding sort of the whole natural history of cardiopulmonary, cardiovascular disease. Next. And next, please. However, in doing this, and this may, is that we also understand there are multiple complexities. We just heard that DB gap has some very complex data, and I think there are a lot of parallels, if not more even accentuated problems in sleep. Because as you can see from these little figures, we collect multiple channels of very different types of data, often even in research contexts that are not as well annotated or standardized, and thus create special challenges to harmonize. But again, the opportunity there is to go beyond the simple summary metrics, which are shown in that patient information kind of summary slide where so much data often gets collapsed, and really expanded to what you see in the bottom of the slide, which is really, maps of quantitative physiologic data across the night that has biological clinical impact. Next. And so when we came about to develop our portal about 5-6 years ago to really address some of these, we wanted to make sure that the impact we had on the community helped address our user community's needs. And what they wanted was they wanted some tools to easily query and visualize data. They wanted tools to allow them to easily aggregate, harmonize data, which are often such a bear in the community. They wanted to analyze data across cohorts that gave them that age spectrum and that spectrum of disease. Our contributors also, had wanted to make sure that what we did, was secure and there was privacy and that there was opportunities to collaborate. Next slide. So back in 2014, with that in mind, the objectives of our repository were to provide our users with these web-based tools to explore this complex data, both within and across data sets, to be able to do queries, to identify subgroups that might be most useful for specific hypotheses. A second area was to really provide the sleep community or the circadian research community a repository to both deposit and access these very rich physiologic signals, as well as link them with other phenotype and even genetic data, and to provide a hub of tools, because a lot of these sleep data really become most informative, ECG, EEG, oxygen saturation, after advanced signal processing is applied to them. And then we also saw the opportunities to link with other resources to enhance, again, the phenotype, genotype data like BioLink and dbGaP and now Biodata Catalyst. Next slide. Next, please. Okay. And so a resource looks like this. Again, we contain polysomnography, actigraphy. We have a number of data sets. We have blogs. We have forum posts. We have opportunities to easily share and upload data. Next slide. And again, just the protocol, we get a lot of different data in, we do a lot of processing, and then we put a lot of data output from everything from protocols to computed signals to the raw data. Next slide. And next slide. And if we look at sort of where we are right now, we have actually from about 27,000 subjects, we have about 32,000 raw sleep studies, that is multiple channel physiologic data. And of those, almost about over 19,000, over 19,000 are from, contain both respiration as well as EEG and ECG quantitative analysis. We also have 7 or more days of actigraphy data on over 4,000 people, and we've put a lot of effort too in the sort of the ontology or the structured vocabularies associated with these data. So we've actually annotated over 5,000 terms. link them to structured definitions, which I'll talk about. And we've also mapped almost 5,000 terms to various provenance attributes. Next slide. Next slide. And again, a lot of pipeline work. Next slide. And then again, sort of one of the things we pride ourselves in is the ability for researchers to very easily query each data set and really understand the metadata behind each covariate and identify those terms and the data that are most relevant for their hypotheses. Next. And another feature is to actually provide analytic tools. And by analytic tools, these are generally signal processing tools, as well as some cross-query tools to really facilitate research. Next. And one of the things that users want more than anything else, too, in terms of addressing impact, is basically a really very transparent and straightforward data use process. And we've developed a very nice, secure, but very easy online data use agreement process that we modeled a lot of the language from BioLink, but in fact, we really facilitated this and even have a local IRB that approves all the requests. Next slide. And then mechanisms for sharing data. Next. Okay, so now that I've told you about this, and I think it was important for you to understand the multiple things we're trying to achieve, I will just really tell you about what we've tried to do to assess impact. And in fact, as a contract and even as a grant, the NIH required us to quarterly report milestones. And we did, in fact, our milestones are really reflected in these broad categories of who is our user base, how many people register, how many people access the data. Do our users, are they productive? And these were, our keynote speaker put this so well, what is their scholarly production? What is the impact on terms of new collaborations, new grants, new funding, the impact on society or science in terms of discovery, and can we help train others? And again, as we heard, many of these things are very hard to quantify, and in fact, the data out there are both hard to retrieve as well as maybe inconsistent depending on what we're looking at. And then finally, one of our goals is to really engage and excite the community and really foster, sharing of ideas and knowledge and further collaboration. And again, very hard to measure. Next slide. Okay, so there are easy things we can do, which we heard are probably very, very insufficient. We have over 6,000 users, and we have almost 2,000 individuals who have approved data use agreements. About 13 million sleep files have been downloaded, or at this, I think we have about 350 terabytes of data right now that's been downloaded. And over the last few years, the number of downloads per week have increased gradually, with both the increase in the user base as well as the increased amount of data in the repository. So about 2 terabytes of data get shared each week. And again, the files are not as big as genomic data. So again, that may be a caveat in how to interpret this. And then we also look at ease of use. In general, it's less than 2 weeks to approve a data use agreement and make all the data a user wants readily available to them. And we also track that. Next slide. Again, we've talked about publications. We tried very, very hard to track this. We've had a hard time. The users, when they actually sign up with the data use agreement, they agree to cite certain specific articles, both from the original cohorts of research studies that generated the data, as well as this resource itself. So there are some challenges, but we know that, and so we easily know that there are, studies that when we track this through PubMed searches, we can easily find somewhere between 50 and 100 studies that cite these, but we're aware that there are many more. So they're very, very difficult, issues in terms of tracking, and we're really, trying to identify easier ways to make our data sets more citable in terms of being citable objects. Next slide. We've also, tried very hard to track those people who used our data to get training grants. Again, that's pretty much at this point a voluntary procedure. We're looking to have conversations with the NIH so that we could actually maybe link some of their information when they grant, these grants that use our data, especially like ARC-21 mechanisms and training mechanisms. But we're aware of, about a half a dozen grants that use these data in the last few years. Next slide. Next slide. We also are very interested in training, and actually high school classes have used our data. And again, we know this from the data use agreements. We also know from the data use agreements that many colleges now use our data as part of, various courses, from data wrangling through their machine learning courses, as well as embedded in biostatistics books for courses. And again, those are very hard to track. We really have to go into our data use agreements and relate to voluntary kind of disclosures. Next. Next. And then we also try to track how many people are excited about contributing data. That's easy to do because we know who's contributing data, but it really relates to all the incentives for data sharing that were talked about before, which not only relates to incentivizing data sharing, but reducing the friction, making it easy for people. Not only what do people should want to see the benefit of data sharing, but we also want to overcome the regulatory and the logistical issues of sharing data. And that's another area. Next slide. The other area to contribute that we're interested in contributing is to the creation of standardized terms. We've deposited more than 5,000 variables that we've mapped into various standardized libraries or mapped them to, controlled libraries like the International Classification for Sleep Disorders, or NIH CDEs, and we've mapped about 4,000 variables to provenance data and deposited those to BioPortal. But those are other metrics that we're interested in tracking. And next slide. So this is my last slide. I'm trying to put forth sort of our unique problems, which may also generalize in many ways. And really, as a potential use case, we clearly have simple challenges in even tracking the citation process, as limited as is, and it really does relate to the citation of the original sources of the studies that go into the resource, as well as the resource itself that aggregated and standardized things. The opportunity to link NIH-funded grants for secondary use in a more systematic way to those that use our resource. Ways to actually systematize our trainee impact that don't relate to just disclosure, voluntary disclosure, and a way to really highlight not only data use, but the tools that we provide the community. So I think my time is out, and I thank you for your patience with me, and I hope I've stimulated some people to maybe work with our group. Thank you.